Hi, today I would like to talk about basic 10 print program or 10 print maze or whatever you want to call it, that thing that you see on the screen. Now at the beginning, just a little side note, from recently we do have 3D version of this 10 print program made by Ian Witham, and together with Robin from 8-bit Show and Tell channel they created like a one-line version of it, and if you haven't seen that I will highly recommend that you do. I will put the links in the description of this video down below. Now, those of you who follow my channel know that I really love Petsky art. I like to play with it a lot. And I do publish from time to time little snippets of code in the community section of this channel, mostly related to these kind of artistic code-generated images, shapes, patterns and whatnot. And I really do enjoy running this on Commodore 64 because it feels so natural. It feels that all those Petsky characters are there just to create those kind of images, and that's the reason why I love this 10 print program also, except for one thing. I don't like to use a random function in this case. Now please don't get me wrong, it's perfectly fine to use a random function, we use it all the time. Just in this case I like to have a little bit more of control over the image that I'm generating. So this is what I would like to show you today, is how can we create a print program without using a random function, and implementability to control to a certain extent what kind of shapes and patterns are we generating. In addition to that, I would like to show you how can we, using the same algorithm, creating the same patterns, just by using a little bit different Petsky characters, we can create completely different images. Or at least that's how our brain comprehends those images. And yeah, that's a really interesting topic by itself. But for now, let's start with some basics. So instead of just using a random function to get random numbers, what we are trying to do here is just to create a sequence of numbers that have enough randomness in it, or they contain certain patterns of repetition and so on and so on. So what we are going to use is, of course, very handy bitwise operators like AND and OR. Of course, we are going to try, there is no function for it, but we are going to use exclusive OR also. And then we are going to use modulo. Also not, there is no function for modulo in BASIC 2.0, but it's very handy. Modulo is very good in creating that randomness in some sequence of numbers. And of course we are going to use division, because that's also a very good tool to slice those numbers and do lots of cool things with it. So yeah, that's basically what we are going to use today, those operations. And of course there is no one way to do it, there's many ways to do this. And just with different kind of combination of those functions, using different numbers and parameters, we can generate really lots of different images and patterns and shapes and whatnot. Okay, now let's take a look at the exclusive OR. How can we calculate exclusive OR in BASIC, and what can we do with it? So let me just switch to white, and let's start by creating two variables, n and m. So let's say that n is 55 and m is 127, and exclusive OR will be n plus m minus 2 multiplied by n and m. So yeah, that should give us exclusive OR. And let's just print that variable a, and let's run it. And now we have 7 numbers 72. Now the point here is to make this little piece of code generate a sequence of numbers. We need a loop, and we need to jump back to the line number 2 and feed a new number to calculate new exclusive OR. To do that, we are going to use the result from variable a. So what we are going to do is we're going to use that result from the previous cycle and use it in the next cycle, right? So let's just, for the beginning, create a line number 4, and this will be just jump to line number 2. So just let's see what do we have now. And okay, so what I will do is I will rename this variable n to variable a. So at the beginning a will be 55, so this will be our seed number, right? And then it will be m plus m, and it will be a plus m, and it will be a and m. So yeah, so if we do this, and now let's run this, and now we have numbers that are just switching between one another, so we can continue developing this. So I would like to subtract a now. So let's see, what do we have now. Now we have a little bit of sequence, and then just always the same number, and we don't want negative numbers, so let's use just absolute value of this, and let's run it now. And I made a mistake. Yeah, I'm missing one bracket, of course I do. Okay, now we have some sequence of numbers. Of course they are repeating, but nonetheless it's a sequence of numbers. So we have 109, 99, 55, 17, 93, 59, 9, and then it repeats itself again. Okay, not too bad. So what else can we do here? Well, we can play with this. We don't have to stick with explicitly using the exclusive OR. What's important for us to have certain algorithm that will just keep running and running and create that sequence of numbers. So if I change this number from 2 to 3, let's try that. Now we have different sequence of numbers, and it looks like it's a lot of them. So let's see, what do we have now. Where can we find some kind of repeating sequence? I'm sure we can, but so 4, 115, 218, 82, 29, 4. Where do we have 4? We don't. Oh, we have a really nice sequence of numbers with this one. So 4 is here, and then where is it? It's here. Did I miss something? Okay, seems like a pretty long sequence of numbers, which is great. I would like to see this. If I end this with 3, because I want numbers from 0, 1, 2 and 3. So let's see, what shall we get now. Is there a repetition? Yes, there is. So let's see, there is always 0, 0, oh, maybe we can try to plot this just to see how this maze will look like. So if we use all these, now what can we do here is let's make some space. It'll print the mid of a string. So we're going to use the mid command, and we are going to create these 4 characters, 4 PETSCII characters, and let's do something like this. And of course something like this. Then because for the mid function we need to use not from 0 to 3, we have to go from 1 to 4. So what we are going to use is a and 3 and then +1. So we are shifting for the 1, offsetting for +1. So instead of from 0 to 3, we're going from 1 to 4, and we are going to just print 1 PETSCII character. Let's try to run it, and we have a sequence of numbers. Okay, now let's try to do something like this, and let's run it now. Hey, we have something. Okay, this looks beautiful, but it's obviously repeating itself very much. It's always the same, but it's something. So if we, instead of just -a, we can add another variable that we have available in Commodore Basic, and that's the position of a cursor. So, and that will change as we print our characters on the screen. That value will change. So let's try to run this now and see what do we have now. Okay, a little bit different, but still lots of repetition. Okay, that's good. So that's what I want to show you about exclusive OR, but we will not just use that. Maybe just change different value. Let's go with 7. What do we get then? Oh, a little bit different. Still repeating itself. Or maybe we need to find a number that will just be 13. So what do we have now? Yeah, completely different pattern. Some waves, some grids. Okay, let's see how we can create a modulo, which will give us much more beautiful sequences of numbers. So now we are recording. I just lost 20 minutes of recording. Never mind. Okay, what we are going to look now is modulo, and how can we calculate modulo, and what can we do with this. So let's start with a similar example. So let's go with the n being, I don't know, 34, and variable m being 9. And the way we calculate modulo is that we take n minus integer from n divided by m, and then multiply everything by m. So let's just print our variable a, and let's run it. It's 7. If we change this 64, let's run it again, it's 1, so it's changing. So what we can do here it's something very beautiful. We can, instead of just declaring this variable n as single value, let's define this variable n as ti, and ti is a basic variable that is time, not really time, it's number of jiffys, so it gets incremented with each cycle. So let's run it now. Oh, we have 4, 3, 6, 6, 6, 7. So okay, let's use ti. This is very nice, but instead of just declaring n variable as ti, let's replace the n variable with ti. So, and that's something completely different, and I will tell you why. Because our basic is a little bit slow and that means that from time to time the value of this variable ti and this variable ti will be different. So this variable ti can have a little bit bigger value than that previous one. For that reason, this algorithm could give us as a result a negative number. We don't want that, so we will just use absolute value of this, and then we don't need this n at the first place. So if I add line number 4 and I jump to line number 2, let's see what do we have now, and let's run this. As you can see, we have sequence of numbers, but there, oh, we have negative number. How the hell did we get negative number? Oh, I didn't press return here. Yeah, my mistake. Are we good now? Yeah, now we're good. Okay, now we have a sequence of numbers which are definitely repeating, but they are even so slightly different from time to time. Something changes, and let's see what else can we do here to make this a little bit more random. Well, we can feed our variable a back to here and just add a. So yeah, let's go with that, because the result of our variable a is always going to be from 0 to 9, and with this then divider is going to be from 9 to 18. Yeah, look at this now. Now we have a little bit different sequence of numbers, and it changes slightly. Yeah, it drifts. Okay, now we have something. So what else can we do here? Well, so this will be a, and if we subtract a from this, what shall we get? Oh, we have negative, a little bit different numbers. So let's remove this bracket and place it right here. Now let's check our sequence of numbers. Yeah, we have a little bit different sequence of numbers now. This could be interesting to see. Yeah, I want to see this. Let's see what kind of 10 print patterns can we create with this. So let's run this. Oh, this is nice. Look at this. This is beautiful. This is really beautiful. And these are not random numbers. These are patterns that we can now control. So if we change something, we should get different patterns. Let's not have A here, let's just use like number 6. So always the same number. What shall we get now? Oh, look at this. It's completely different. Now we have some real separate sections and everything is leaning to this side. Now we're switching side to this. Yeah, look at this. Oh, we are zigzagging. This is beautiful. Look at this. I mean, you have to see that this is not just random characters, this is art. Yeah, okay, we are starting to repeat ourselves. Yeah. Yep. Okay, very nice. So far, so good. We still didn't combine those two, modulo and exclusive OR, and there is so many things that we can do still. We didn't add any ANDs or ORs or whatever, so we can now play with this. So if I AND this, let's go with, let's say that M is like real big number like 127, and we should end it with A plus 3. The reason why I add this A plus 3 instead of just A is that in the beginning the A is 0, so the M will be 0, so just to avoid that. What do we have now? Oh, look at this. Yeah, look at this. We are changing a little bit. So let me show you what will happen if we change this just a little bit. So instead of these two inner slashes, we change this to one Petsky character that combines really nicely with those slashes. So, and that's this one. So let's go. Look at this. It's the same pattern, same code, same algorithm, and we can see completely different things now. It's a completely different image, and our brain cannot connect this to that previous image, which is beautiful in a certain way. Okay, let's make this a little bit smaller number. We don't need 127. Let's go with 15, and that should be enough. Okay, a little bit nicer. But what if we change this a little bit more? So what if instead of these Petsky characters we use something else? Let me just create this, then I will explain. Let me run it. Oh, we are not done yet. Haven't changed everything, so let's change this to 2. So this, if we end with 2, then we will get 0 2 0 2 0 2 0 2. When we add this 1, what we will get is 1 3 1 3 1 3 1 3, and instead of one character we are going to print 2 characters. So this first character that we are printing is going to activate reverse on the keyboard, and then we are going to print this pesky character, and the second set is going to disable reverse on, so we are going to back to normal and then print this pesky character. So let's see, what do we have now? And look at this image. Again, same pattern, and we see something completely different. Oh, we have this, oh, and we're shifting and changing. Oh, I want a little bit more of these, so let's go by, maybe I want to add a, so we will get some bigger numbers. Look at this, and look at this. Now this looks like I don't know, surface of the moon, or something like you look through the microscope and you see this. I don't know, but this is beautiful. Look at this. Okay, let's see how can we control this a little bit more than just a little bit more effectively, not just by me stopping the program, changing some value and so on. And let's see how can we now combine those exclusive OR and modulo and some other stuff, you know, together and create something even more beautiful. So yeah, that will be our next step. What do we have now is this, and this is the combination with modulo and exclusive OR. Both of them are a little bit changed. So let's run it and see what kind of patterns do we get now. Oh, this is beautiful. Lots of repetition, but really nicely made. You know, looking at this, you can see how these patterns are evolving and changing to something else. It's not really, it's not random. With random you get all sorts of things. This is very elegant and beautiful. And slow. It's slower, it's definitely slower. But that's not the point. We are not here to make fast 10-print programs. We are here to enjoy these beautiful patterns that appear in front of our eyes. And now let's implement something that we can control these patterns without actually need to stop the program. So we can implement some kind of control, let's say over these two variables, let's say for this x. So what I'm going to do here is I'm going to just list 1. We don't need this. So I will add line 0 and I will define our variable x as 11. And here, and I will define variable y as 9. So here, first of all, we will use get key. So we will try to capture key pressed on the keyboard, and then we will say that x is equal x minus, and then if k is greater than 0 and k less of 9. In that case, let's multiply everything with a k. So what this will do for us, every time that I press some number between 0 and 9, so 1, 2, 3, 4, 5, 6, 7, 8, that number will be added to the variable x. If none of the keys are pressed, then x will remain the same. Yeah, that should be it. And what we need now, instead on this line 5, instead of going to line number 2, we need to go to line number 1. So at the beginning, everything should appear very normal, and some patterns will start to generate. Let's just see what will happen. Yeah, okay, maybe we see this before. So let me press just 1. And this should change the pattern a little bit. And it did. See, it's a little bit different now. Let's press 4. So we added 4. And now we are changing the pattern again. Let's go with 8. Oh, now we're speeding up, changing the patterns. How about 5? 5. Okay, did we get something new? No. 5 again. Oh yes, we are changing. We didn't have that 888, 000, 88, whatever it is. Okay, let's go with some more values here. Okay, we are changing again. Again. Nice. And as you can see, it's kind of beautiful change. It's elegant, it's nice. It's not really, you cannot tell where it actually begins to change and where it ends. Just suddenly appearing different patterns. Look at this. This is beautiful. Okay, I must stop this, and I need to change those pesky characters to see. Oh, look at this. It's nice, it's beautiful. Let's stop it. Let's do some changes. Of course, we are going to do first with Shift V. So we are adding those, and let's go with 3. That should be enough. Let's run it now. Look at this. It's the same pattern, same algorithm. It's almost this completely different image. You can barely notice that there is 10-print program behind this. And if we implement a little bit of color, it will be even more. Yeah, we should do color. We should implement color. But let's just add a little bit more. Let's change those values. So I pressed 5. So we have a little bit different patterns now. Oh, 5 is nice. 5 is very nice. And then add 6. Oh, we're changing again. This is beautiful. Now I need to try the reverse keys. So how was that? It was Control R, Shift V, Control 0, Shift V, and we need end it with 2 and just print 2 characters instead of 1. So let's go. Ooh, we have a lot of blobs. It's beautiful. Okay, let's add 5. A little bit different pattern. Okay, nice, nice. It is slow, it's very slow. Lots of white. Yeah, we need something like... Okay. Changing. We are changing. Again, this is nice. How about changing the color? I would like to try that. So let's go how to change color. So instead of reversing those values and those pesky characters, let's just change the color of those pesky characters. So let's say that we want this is black. Okay, we don't need black. We do need black, but okay, now we need 1, and then we need Shift V, and then we need 2, Shift V. So this should give us black and white. Instead of reverse on and reverse off, we should get black and white. Yeah. Let's check this out. Now look at this. Now our black characters looks like they're a little bit behind, right? Look how beautiful is this. Again, using the same pesky characters, changing a little bit of color, and we can see completely different image. Look at this. Lots of black. Yeah, what's happening here? We are shifting somewhere. Oh, this is nice. This is nice. And how about changing those X's to slashes? So yeah, what we will see then. So I need just Shift N and Shift M. So how about this? Now those are the same patterns that we just looked before, and there is no way that our brain can connect those two images. No way. This is a completely different story. Yeah. Oh, we need to combine. We cannot just... this is not really good because... yeah. We need to create... let's switch to this. We need to create more of these. So what I need to do is black, create this in black and this in white. So I need another like so. And then I need more spaces. Yeah, please don't do this to me. I need this, and I need this, and here I need more spaces. So what what are we going to do is shift control 1, and then we have shift M, now we shift M, and then we need control 2 and then shift N. Did I get this right? And we need, so now we have we need 1, 2, 3, 4, and 4 we can get by 3 plus 1. So no, this multiplied by 2 plus 1. So it's 2 plus 2, it's 5. Yeah. So we need to multiply by 2. Yeah, here we go. Now look at this. What do we have here? Let's go ahead, a little bit more white characters. Yeah, go, go, go. This is weird. Okay, let's take a look at this example, and this is something that is a little bit optimized. The idea behind this example is just to make a one-liner 10 print program without using a random function and still have interesting enough patterns created on the screen. So yeah, and I've been playing with this one for a while now, so let's run it as it is now and let's see what do we have. So as you see, we have lots of repetition, we have long shapes, and we are changing. Look at this, now we are in these diamond shapes, and now we're going to drift again and change to a little bit of this little waves. Okay, still have these diamonds. Oh, okay. Do we have anything new, or are we going to just repeat? Oh, we are changing a little bit, so let's see. But let's play around with this one. So what can we do here? We have a couple of parameters, but let's go with this divider here for modulo, right? So now we should get something a little bit different, and we do. Okay, let's try something else. This is 18, 63 should be like all ones in the lower significant bits. Okay, now we have something different. Okay, let's see how this will evolve. Okay. Yeah, I like this one. I think I'm going to change the characters to see what else can we get from this algorithm. We need 2 more spaces, so something like this. Yes, don't do this to me. So we need Shift R, Shift V, Control 0, Shift V, and we need 2 and 2 here. So Let's see, what do we have in this version? Okay. Again, we have some clusters. It's not very different from last. Oh yeah, we have clusters. That's nice. That's nice. Okay, let's try to change a little bit these characters to see can we get something even different from this. Let's go with these circles. What shall we get here? Oh, okay, look at this. Oh my god. This is actually nice. It's weird. This is really, really nice. How about instead of that full circle, maybe we can use like dot. If we change this like a single dot, so how about now? Oh yeah, this is interesting. Now those clusters again they're more visible, and yeah, look at this. This looks like fucked up Tetris. Yeah. So yeah, I think I'm going to finish this video with this Tetris kind of like image. So last Sunday, I believe it was last Sunday, it was my first appearance in some live chat with some other fellows here on YouTube, and I really had lots of fun doing that type of video, and I think I'm going to do it again, so you can expect a little bit more live streams and live videos from now on. If you want to see a little bit more of a repair videos and how to fix our beloved Commodore 64 or some other consoles and machines, I will put the links in the description of this video for some other fellow YouTubers, and you can check them out. So yeah, and this is all that I have for you today, so until next time, goodbye.